In this course, we're going to explore a practical real-life scenario focusing on how a two-person team can effectively use Git and GitHub to collaborate in building a front-end website. But the main objective here is not about how to build a website. The goal is to equip you with the skills to effectively utilize Git in any project you undertake, whether you plan on working just by yourself or in a team. By the end of this video, you'll have a solid understanding of Git and be able to incorporate it seamlessly into your own projects, whether you're developing software, building websites, or engaging in other group collaborations. So let's begin by introducing our two-person team as they start on their journey to build a front-end website. Our development team consists of two people, Mark and Emily. Mark is a front-end junior developer with 18 months of experience in website development. While he possesses some knowledge of Git, he doesn't yet have the expertise to lead a project. Emily, on the other hand, is our experienced lead developer with over 7 years of industry experience. She has successfully collaborated on multiple software projects using Git and will take charge of managing this project. Their objective is to construct a website for a charity, aiming to achieve a final result similar to the one showcased here. And to ensure seamless collaboration, Mark and Emily have opted to use Git as their version control system. Now, as part of their collaboration process, Mark and Emily are going to implement a pull request workflow, which involves a couple of steps. First, Mark will complete his assigned task or feature and submits it to Emily to assess. Emily then carefully reviews Mark's work, offering feedback to him to address any necessary adjustments. Once the changes align with the desired standards and objectives, Emily approves the request and integrates Mark's work into the main project. As we move through this course, we'll see exactly how this process is done step by step. Now, Emily and Mark have both agreed on this style of workflow, but there are many other ways teams can collaborate together, depending on their project and team dynamics. I won't go into these styles and workflows here, but if you want to know more, you can read Chapter 5 of this free book on the Git website. Before we install Git, it's important to fully understand how Git works, particularly the 3 stages of the Git workflow, which are the working directory, the staging area, and the repo. Typically, when a developer wants to start a project, they would initialize a Git repo inside a folder that will serve as the project's home on their local machine. This action will generate a hidden folder named .git, which contains all the necessary files and metadata to manage version control for the project. This Git folder effectively acts as the repo's backbone, holding important information about the project's state and its evolution over time. Now, when new files are added inside the project folder, Git examines its history to determine whether these files have ever been added to the repo before. If the newly added files have never been included into the repo, Git recognizes them as untracked files. This means that Git doesn't consider them for version control by default, and any changes made to them will not be recorded. But if you want to start tracking these new files, you need to explicitly inform Git that you want to include these files in the repo's version control system. This process is called staging, and these files will be sent to the staging area. Staging prepares the files to be included into the project's history. Once staged, the files will be tracked, which means that Git will now monitor them for any changes. Once the files are changed, we can make a commit to the repo. The repo is where all the committed snapshots of the project are stored. Each commit represents a point in the project's history and contains a reference to the changes made, along with a unique identifier. The repo allows us to track the progress of the project, revert to previous versions if needed, and collaborate with others. By understanding these 3 stages of the Git workflow, you'll be able to better understand the commands that Emily and Mark use and why they're using them. With this knowledge, we can now proceed to install Git. Before Emily and Mark get started on their website, they need to ensure Git is installed on their local machines. This process will be different depending on which operating system you have, but you can navigate to the Git Downloads page and follow the instructions from there. Alternatively, you can read more detailed instructions from their free book on chapter 1.5. In our imaginary scenario, Emily is using Ubuntu, which makes installing Git probably the most straightforward for her. After opening a terminal, she can type sudo apt install git all. And after the installation is complete, she can type git version to ensure it's installed properly. Mark, on the other hand, is using Windows and will need to install Git Bash, which she can do by navigating to this website and downloading the latest build. So installing Git Bash requires a few more steps for Mark, but it's still fairly straightforward. He should be able to keep the default options as they are, and once installed, he can open up Git Bash and test the version. Now that Mark and Emily have Git installed on their systems, they should customize their Git environment. The first and most crucial step is to set up their username and email address. Configuring the username and email address in Git is essential because it ensures that the contributions made by Mark and Emily are properly attributed to them. To set their username and email address in Git, Mark and Emily can use the following commands in their Git Bash or terminal. The global flag ensures that their usernames and email addresses will be applied to all Git repositories on their local machine. This means they'll only need to do this configuration procedure once, and Git will automatically use these values for every commit they make. It also ensures that their user information is consistent across all projects they work on. And if you want to check out the Git environment settings, you can type git config list. And on Emily's Ubuntu machine, you can see her name and email are correctly added to the environment settings. Mark will have a more complicated output on his Git Bash terminal, but his name and email should also be displayed here too. Emily is the tech lead for this project, so she will be the one to set up the project and initialize the Git repo. Now, she could do this in two ways. She could initialize the project remotely on a hosting platform like GitHub, GitLab or Bitbucket, and then clone the repo down to her local machine using the git clone command. Alternatively, she can initialize a new Git repo on her local machine with the git init command, and when she's ready to share the project or collaborate with others, she can push her local repo to the remote repo using the git push command. Now I'm going to show you how to do the latter, as it will also demonstrate how to use Git when you don't have immediate plans for sharing or collaborating with others on a project. When we get to Mark a bit later, he will be cloning Emily's project repo from GitHub, and we'll go through the exact steps he'll need to take to accomplish that. So first, Emily needs to create a folder to house the website project, and she can do that by changing directory and then use the make directory command to create a new folder called website project. The ls command allows Emily to list all files and folders in the current directory. And we can see here that Emily's website project folder has been created successfully. We can also see this on our desktop. Once she's changed directory into this file, she can run the git init command, which will generate an empty Git repo in the current directory. And the ls-la command simply shows us all the folders including hidden folders, as well as their file permissions. Now from this point, it's always worth running the Git Status command. Git Status provides valuable information about the current state of the Git repo. It shows which files have been modified, which files are staged for commit, and which files are untracked. It also provides helpful guidance on the next steps to take based on the current state of the repo. Let's break down the response from Emily's Git Status command. The message on branch master indicates that Emily is currently working on the master branch. The master branch is the default branch in Git and represents the main line of development. Any changes or commits made at this point will be part of the master branch's history. We'll talk more about branches later. Because Emily's repo is brand new, the message, no commits yet, indicates that she hasn't taken any snapshots of her project yet. In other words, she hasn't saved any changes or recorded any history in Git. The nothing to commit message means that she hasn't staged any files yet. It also gives her helpful tips on what to do next. It tells Emily, she needs to create or copy files into her project directory and then use the Git Add command to stage them. If she doesn't stage them with this command, they'll remain untracked. So Emily is now using the touch command to create 2 empty files within the website projects folder. She also wants to create a folder called images, which she'll use later. Now when she does a git status again, we see her newly created files are listed as untracked files in her working directory. Untracked files can be added to the staging area individually using the command git add and then listing the files one by one. Or they can be added all at once by placing a period after the add command. Doing a git status again, we can see that her files are highlighted in green. This indicates that the files have been added to the staging area and are ready to be committed. If Emily commits these changes, the files will become part of the project's history and be stored in the repo. But let's say Emily has made a mistake and doesn't yet want to include the style sheet in this current commit. She can remove this file from the staging area back to the working directory using the git remove cached command. We now see that the style sheet has reverted back to being untracked and only the home page is ready to be committed. In this case, however, Emily does want the style sheet included, so she'll add it back to the staging area. Finally, Emily commits her changes with the git commit command. The M flag allows her to write a commit message. Now it's important to write a descriptive summary of the changes made so that others can quickly understand the purpose of the commit. If you're working in a team, other developers will pull your changes down from the server and look at the latest commits to keep up to date with what's going on. Clear commit messages will be appreciated. After Emily hits enter, we can see that 2 files have been added to the master branch on her local machine. And because these files are brand new to the repo, there are no recorded code insertions or deletions. But later, when working with tracked files, or in other words, files that have been previously staged and committed at some point, we will see how many lines have been modified in each newly committed file. To view all commits made so far, Emily can type git log, which will display all the commits in reverse chronological order. But every commit consists of several useful elements. First is the alphanumerical hash, which uniquely identifies every commit in this repo. We then have the author and the date of the commit. And lastly, the message Emily typed out while making the commit. There are in fact additional options you can tag on to the end of the git log command, which you can use to format and filter this list based on various criteria. One example is to tag the word one line on the end of the git log command. This option prints each commit on a single line and is really useful if there are many recent commits. And if we look carefully at Emily's commit message now, you'll see that she's made a spelling mistake. Emily isn't happy with this spelling mistake, so she's going to amend her commit message. The Git Commit Amend command allows you to undo a previous commit, and you might want to do this if you've messed up your commit message or if you've forgotten to add some files. However, it's important to note that when you do amend your previous commit, you completely overwrite it with the new changes you have in the staging area. This means that the previous commit will no longer exist in its original form. Emily's staging area is currently empty, so the files within this amended commit won't change, but she'll be given the chance to modify the commit message. When she types Git Commit Amend, it will open up her default text editor, which is Nano in this case, and she can correct her commit message here. Alternatively, she can write Git Commit Amend-M and write a new message directly in quotes. You'll also notice that even though this previous commit has been overwritten, it now has a new hash value. But viewing all her files in her project folder, Emily realizes that she should probably include a robots.txt file. And instead of creating a new commit, she decides to amend her first commit again. So she creates the robots file with the touch command. adds the untracked file to the staging area, and then performs another Git Commit Amend. Now this newly overwritten commit has all the necessary files and folders to begin building a new website. It's very important to emphasize that you should only amend commits that are still local and have not been pushed to the remote server. Once you push a commit to the server, it becomes part of the repo's history and is visible to others. Amending commits that have already been pushed can cause issues and complications as it changes the commit history and can create conflicts for other team members who might have already based their work on the existing commits. Emily's next task is to create some HTML code to provide a starting point for Mark. This will involve writing boilerplate code and providing instructions on the desired appearance of the website. Once Emily completes this task and makes several commits, she will proceed to set up a GitHub repo, and from here she will push her local repo to the GitHub repository so that Mark can clone it and continue working. Emily can easily open up VSCode on her terminal by using the command code followed by a period. The period indicates to VSCode that it should open the current directory, which in Emily's case is the website project. Once VSCode is open, all the project files can be found in the Explorer tab. VSCode also recognizes that this folder contains a Git repo and displays the current branch. While we can perform source control tasks in VSCode, we'll currently focus on the command line interface for now. Emily has enabled autosave from the file menu, which ensures that any changes she makes are automatically saved. The Source Control tab in VS Code reflects these modifications and marks the modified files with the M flag, and this is equivalent to doing a Git Status on the command line. Additionally, by clicking on a specific file, VS Code provides a helpful side-by-side comparison of all the changes made since the last commit. Now going back to the command line, we can use Git Diff to achieve the same effect, and it breaks down exactly what code changes we've made since our last commit. This output is more complicated, but I'll break down the most important elements. Git Diff is comparing two files here. A/home represents our home page in our working directory. This is the file that Emily most recently committed, and B/home is our modified file. The next line indicates there's a change in the code that starts at line 0, both in the original file and the modified files, but only one line was added to the modified file, which is shown in a green font below. So Emily is now opening up VS Code and writing some HTML, as well as instructions for Mark. She has also included some example stock photos and placed them in the images folder. If we look at Emily's commit history, we can see that she's made 3 commits. The first was setting up the files and the folder structure. The second was to include boilerplate code and instructions for Mark. And the third was including placeholder images for Mark to experiment with. Emily's next step is to push her local repo to the remote server. First, Emily needs to set up a GitHub account. Once navigating to github.com and clicking on the pricing tab, she has 3 options to choose from. The free version is good enough for this type of project. All she needs to do now is create an account. It's also worth mentioning that Mark will also need to create his own separate account to be able to collaborate with Emily on this project, but the steps are exactly the same. Once logged in, Emily should see something like this. On the left-hand side, there's a green button called Create Repository. Now, Emily needs to click on this button rather than the Import Repo link. You'd click this link if you wanted to import a project from another version control system, like Subversion or Mercurial. Clicking on Create Repository will lead her to this page, where she'll enter the name of the project, write a short description, and choose whether to have this project private or public. Because Emily and Mark are working on a project for a client, they'll need to keep this project private. She can ignore the other options for now, and just click on the Create Repo button. From here, Emily is given a couple of options. If Emily hadn't initialized her Git repo on her local machine first, she could have cloned this empty GitHub repo down to her local machine using git clone and copied this address here. But since she's already established a repo on her local machine and made a number of commits, she'll need to push her existing repo to GitHub using these commands. We'll discover in a minute that GitHub won't allow Emily to connect through this protocol, and she'll need to switch to a secure shell. But we'll fix this in a minute. For now, Emily should just copy these commands into her terminal. First, Emily must ensure she is inside her local project directory. Then she can use the git remote add origin command to set up a connection or link between her local GitHub repository and her GitHub repository. Origin here is just a shorthand reference to the remote repo. This command here is used to rename the current branch in Emily's local repo from master to main. And the last command, git push origin main, is used to push Emily's local branch to the remote repo. And the U flag is short for set upstream and will allow Emily to use the shorter commands like git push or git pull without needing to specify the remote and branch every time. But Emily now runs into her first problem. She needs to enter her username and password, and after successfully doing this, she gets the message saying password authentication is no longer allowed and that her attempt to push her local repo to the remote server failed. In order to fix this, Emily needs to create an SSH key so she can connect to GitHub over a secure shell. To do this, she needs to click on her avatar icon in the top right-hand corner in the GitHub account. Select Settings, and over on the left-hand side, click on SSH and GPG keys. Currently, Emily has no SSH keys associated with this account, but she can click on this link to follow a guide that will walk her through the steps of generating a public and private key, as well as establishing a connection via SSH. We'll go through these steps now. If she's unsure whether her machine has been set up with an SSH key pair in the past, she can click on this link, which will show her how to check for existing keys. Because Emily knows no keys exist on her laptop, she's going to skip this step and click on the Generate a new SSH key link below. Now here, the setup steps are slightly different for each operating system, so the correct one must be selected. Scrolling down, she comes to the heading Generating a new SSH key. There are a couple of steps necessary for generating both the public and private key from Emily's laptop, and then setting up the SSH agent to manage those keys. First, Emily copies the SSH keygen command and then pastes it into her laptop terminal, which generates a new SSH key pair. After replacing the example email address, she is prompted to choose a file location to save the key, but by hitting enter here, the key pair will be saved in the default location. Next, the prompt asks Emily to enter a passphrase, but this can be left blank. After hitting enter twice, she's presented with the locations of her private and public keys, as well as a random art image. So Emily has successfully completed steps 2 and 3. Next, Emily needs to start an SSH agent in the background, and she can do this by pasting this command into her terminal. She then uses this command to add her newly generated private key to the SSH agent. And just a quick note, this directory address and private key name must be the same as it is on her local machine. The next step is to copy over the public key from Emily's laptop to her GitHub account. So clicking on that link and scrolling down the page a bit, Emily can copy the cat command, paste it in her terminal and view the contents of her public key. This public key can then be copied to the clipboard and added as a new key here. A title isn't needed, but she must make sure that the key type is an authentication key and then click Add SSH Key. Now Emily's public key is stored on a GitHub account. She can test her SSH connection by typing ssh-t github.com and checking this fingerprint against the hash on GitHub's website, and I've placed a link in the description to this page. If the hashes match, it means that Emily is in fact connected to GitHub, and GitHub will be saved in her known hosts file after she types yes into her terminal. Finally, Emily needs to change the address of the original repo. When she does a git remote-v, we can see that Emily's GitHub repo address uses this protocol, and that now needs to be switched to SSH. Initially, when setting up the GitHub repo, Emily was instructed to use this command with this address here. But this protocol won't work. She needs to click on the SSH button and copy down the SSH address. She then needs to go back to her terminal and change her original address with the git remote set URL command, like so. Now she can push her local repo to the GitHub account with the git push u origin main. And that's it. Emily's local main branch is now set up to track the remote main branch, which allows Emily to simply type git push to push up further changes, or git pull to pull down changes from the remote branch. Going back to GitHub, we can see that her project is in her GitHub repo. Now that everything is set up on Emily's end, she needs to add Mark as a collaborator. First, Emily needs to click in the Project Settings tab, navigate to the Collaborators button on the left-hand side, and then add Mark. She needs Mark's GitHub username or his email address, and Mark needs to be set up on GitHub before he can be selected as a collaborator. But once Mark is added, Mark should now receive an email with the invitation and can accept it from here. Or he can log into his GitHub account, click on the bell icon in the top right hand corner and accept the invitation from here. Mark now has access to the private repository and can clone the repo to his local machine. But since private repos require authentication through SSH keys or personal access tokens, it's best that Mark sets up an SSH key pair for his own account. Now we've already been through this process with Emily, so I won't repeat this here, but the instructions are nearly identical. Once Mark has set up his SSH key pair and tested his connection, he can clone the repo down to his local machine. The best thing to do is copy the SSH address under the Clone tab and do a git clone from git bash. Now Mark can run the git log command to view the commit history of the project, which includes the changes made by Emily. Under this current setup, Mark can now make local commits on his machine and then push them to the main branch on the remote server. However, this is generally considered bad practice because directly pushing to the main branch can lead to potential issues such as conflicts or unintended changes impacting the entire project. So instead of pushing his changes directly to the main branch, Mark needs to create a new branch on his local machine where he can work on the project independently from the main timeline. If Emily makes more commits on the main branch on the server, Mark can pull down her changes and his main branch will continue to grow independently from his feature branch. Once Mark finishes work on his feature branch, he can push his entire branch up to the remote repo for Emily to merge into the main branch. By using the git branch command, Mark can see all branches that are within his local repo. Since he's just cloned the remote repo, he only has one branch called main, and the star indicates he's checked out on that branch. So if Mark makes any commits on his local machine, they'll be added to the tip of this local main branch. In order to create his own branch in his local repo, Mark can type git branch and then the name of that branch. Mark can now view all branches both on his local machine and on the remote repo by using a -a flag after git branch, and this shows us a couple of things. The current branch Mark is in is marked with a star and highlighted in green. All other branches are in white. All remote branches are highlighted in red. And Mark's output states there is only one remote branch named main, and that his local repo is tracking the state of branches on the remote repo. And just to note, all of this is done automatically when Mark ran the git clone command. Now, in order for Mark to work on the home page without affecting the main branch, he needs to switch to his newly created Mark's work branch. He can do this by using git checkout and typing the name of the branch. When Mark does a git log, we can see head now points to Mark's work branch, meaning that any commits made by Mark will be added to this branch while keeping the main branch untouched. Mark can now open up VSCode and start working on the homepage. After finishing the website's navigation bar, Mark decides it's a good place to commit his changes to the local repo. This process is exactly the same as the one Emily went through when doing commits on her local machine. First, he does a Git Status to see what files have been modified in the working directory. He then needs to decide what files should belong to the same commit and then stage just those files with Git Add. After Mark is happy with the staging area, he can commit to his local repo. This has now added a new commit to Mark's work branch. As Mark continues this process of making modifications to the homepage and committing in blocks, he ends up with a total of 5 commits. So Mark's local repo now looks like this. And this is what the website looks like at the head of Mark's work branch. By switching back to his local main branch using git checkout dash or git checkout main, the head pointer now moves back to this commit here, which was Emily's last commit, and we can now also see this by refreshing the homepage. But all the work Mark did still exists, it's just on a separate timeline. While Mark works on the homepage, Emily can still work on the site at the same time and make commits herself on her local machine. If Emily then pushes those commits up to the GitHub server and merges them to the main branch, Mark's main branch on his local machine would be out of date. So it's important for all developers working on the same project to check out into the main branch and then do a git pull on a regular basis. This will download any new commits to the local main branch on the developer's machine. It's important to note here that Mark's work branch only exists in his local machine and will not be present on the remote server. If he wants others to collaborate with him on this branch, he would need to push that branch up to GitHub. After doing a git pull on the main branch, Mark gets the message, everything's up to date. This means that nothing has changed on the remote server since Mark last cloned the repo. So at this point, Mark can push his branch up to GitHub using git push origin Mark's work. And from here, he would log into his GitHub account and do a pull request. But before we look at how Mark will do a pull request on GitHub, let's rewind for a second and imagine Emily has pushed a new commit to the main branch on the remote server while Mark was working on his changes in his local machine. If we look at the main branch on the remote server, we can see that Emily has decided to include an about page and has updated the robots.txt file. This means that the remote repo is now ahead of Mark's local repo by 1 commit. So if we go back to Mark now, who is just finishing his work on his local feature branch, when Mark switches to his main branch and does a git pull, he will receive Emily's changes. His main branch will now be up to date with the remote server, and his local repo will look something like this. And doing a git log now, we can also see the head is now pointing to Emily's latest commit on Mark's local machine. Now in this situation, there are a couple of things Mark can do. He can still push his branch to the remote server, do a pull request and have Emily sort things out from there. Or he could do something called a rebase before he pushes the branch. So to explain what rebase means, we need to have a look at the current state of Mark's local repo. Since Mark just did a git pull, his local main branch is identical to the remote, but the main branch and Mark's work branch have now diverged. If Mark wants to incorporate his changes into the main branch, he could perform a merge, but doing so leads to a more complicated and non-linear history of events, and this can make it harder to understand exactly what happened and in which order. What a rebase does is take all the commits in Mark's work branch and reapply them on top of the main branch. Essentially, it replays these commits on top of the main branch, resulting in a linear history that appears as if all the work happened in a series. This can make it easier to understand the history of the project and see how changes were introduced. Now, rebasing should not be done on any branch that's already been pushed to the remote repo. This is because rebasing modifies the commit history. If others are already working with the existing commits in this branch, it can lead to conflicts and difficulties when trying to synchronize changes. So only perform a rebase on a branch if you've created it on your local machine yourself and it has never been pushed up to the remote server. To rebase, Mark checks out his work branch with the git checkout command. Then he types git rebase origin main, and what this does is fetch down the latest commits from the remote main branch and replace Mark's work branch on top of it. When Mark does a git log, we can see that Emily's latest update comes before the commits in Mark's branch, and there is now a linear history. Now, doing a rebase can cause merge conflicts, but we'll get to this a bit later. Mark can now push his branch to the origin, in other words the remote repo, using git push origin Mark's work. And GitHub now indicates it has received the new branch. And that's it. So Mark needs to log into his GitHub account now and do a pull request. A pull request provides a way for Mark to notify Emily about the changes he's made. Emily can then review, discuss, and eventually merge his changes into the main branch of the repo. So when Mark logs in, he should see a notification that his branch has recently been pushed. After Mark clicks on the pull request button, he'll be able to write a description of the branch he wants to be merged. And if he scrolls down, he'll be able to see all the commits on his branch and a more detailed breakdown of the code changes. All that's left to do is to click on Create Pull Request. Now he could merge his own pull request here, and this could be useful if Emily was unable to continue working on this project for some reason. But in this current setup, Mark has agreed that Emily will be in charge of maintaining the remote repo. When Emily logs into her GitHub account, she can access Mark's pull request from the bell notification, and from here she can review the work and directly merge Mark's changes if everything looks good. Now Emily has 3 different ways she can merge Mark's branch. The merge commit is where you have the option to unite changes from 2 different branches into a single unified branch in Git. But because both branches have diverged in Mark's case, there will be no linear history of events when the merge takes place. This is not necessarily a bad thing, but it can make the commit history a bit complicated to unravel at a later date. The rebase and merge option is the same as the process Mark chose when he rebased his local branch on his local machine. If Mark decided on just pushing his local branch up to GitHub without rebasing, Emily could perform the rebase from here. The last option is to squash and merge. When you squash a branch, all the commits are combined into a single commit. But before Emily merges Mark's branch, she wants to pull it down to her local machine and view the website on her browser. And she leaves a note for Mark informing him that she will test out the homepage and come back to him if she needs any changes done. After Emily does a git log on her local machine, we can see that her local repo does not yet have the latest changes from the remote. Also, her local repo is only aware of the main branch on the remote server. Doing a git pull will download the latest commits from the main branch, and it will detect any new remote branches. When Emily runs git checkout Mark's work, she is creating a branch called Mark's work on her local machine and configuring it to track the remote branch. This allows her to push and pull changes to and from the remote Mark's work branch. On this occasion, however, Emily is simply going to view Mark's work on her browser. Doing a git branch shows Emily she is now successfully checked out into her local Mark's work branch. By navigating to her work folder, she can open up the home page and now view it on her browser. From here, if she wants Mark to make changes to some aspects of the home page, she can communicate with him within the GitHub comments, and the whole process can repeat. Do bear in mind that Mark should now avoid rebasing again, because Emily has a copy of Mark's branch on her local machine. Once Emily is happy with Mark's work, she can navigate to the Pull Requests tab on her GitHub account and now merge his branch into the main branch. Also notice that this branch has no conflicts. Conflicts usually arise when multiple developers have made changes to the same file and attempt to commit it to the same branch. When this happens, someone will need to look at the file and manually choose whose changes to keep. We'll talk more about conflicts and how to resolve them shortly. Since there are no conflicts, Emily decides to squash all of Mark's commits into a single commit and then merge it into the main branch. Once merged, the branch is no longer needed, so Emily can delete it from here. Now, the branch on the remote server should look something like this, and Emily and Mark can check out their local main branch and pull down the latest changes. The last thing Emily and Mark need to do is to delete the Mark's work branch from their local repo using git branch -d Mark's work and to run git remote prune origin. The prune command will remove any remote tracking branches in the local repo that are no longer present on the remote server. Now we're going to get into a situation where a conflict arises. Let's say Emily logs into a GitHub account and makes a quick edit of the home page. She makes a change to the charity's address and phone number. She then writes a quick commit message before directly committing to the main branch on the server. In the meantime, Mark needs to make a change to the home page as well. He decides to make a new branch in his local repo and he uses a new command, git checkout -b Mark's changes. This command generates a new branch and checks it out in a single step. Opening up VSCode and navigating to the homepage file, you'll notice that the address and phone number haven't been updated yet, and this is because Mark hasn't pulled down the latest changes from the remote. Despite this, Mark makes changes to the email address. Now he could go back to the bash terminal, but Mark chooses to stage his changes within VSCode by opening up the version control tab and clicking on the plus button here. Once staged, he can view the differences between his staged file and the original file, and this is equivalent to doing a Git Diff on the command line. Mark is happy with his changes, so he writes a commit message and makes the commit. Now Mark can publish his branch from here, but he wants to do a rebase first to replay any new commits on the newly created branch. So Mark switches to his main branch and does a git pull, which adds Emily's changes to Mark's main branch. Now at the moment, Mark's local repo doesn't detect any conflict, and that's because the changes done to the home page by Emily and Mark are in separate branches. But when Mark attempts to do a rebase, this is where the merge conflict arises. Switching back to Mark's changes branch and doing a git rebase, Mark receives the message that his commit cannot be applied and that there is a merge conflict in home.html. In order to fix this, Mark needs to open the file to see exactly what the issue is. Now VSCode really helps us out here by highlighting the lines of code that are in conflict. Under the heading Head Current Change, we see Emily's commit from the remote, and between the equal sign separator and Mark's commit hash, we see Mark's changes. From here, Mark has a number of options he can choose from. he can accept the current change, in other words, keep Emily's changes and disregard his own, or he could accept his change with Emily's being removed, or accept both changes, which will include all 6 lines. Mark's merge, however, is a bit more complicated, so he'll have to make changes manually. He wants to keep his modified email address and also keep Emily's address and phone number changes, so he copies his email address change into Emily's changes and removes his code below, as well as the conflict metadata. He can now stage his changes by clicking on the plus icon and clicking Continue to commit. Now, doing a Git Rebase once more simply ensures that nothing new has been added to the main branch on the remote server while Mark was fixing the merge conflict. Since the branch is up to date, Mark can now push his branch to the remote with git push origin Mark's changes. And just like before, he will need to log into GitHub and do a pull request, allowing Emily to inspect the changes and then merge them if they're acceptable. So far, we've followed Emily and Mark as they work together to build a front-end website for a charity. Now, this is only an example, but it covers the most fundamental stages of the Git workflow that you would need for this type of scenario. Keep in mind that Git offers you much more than we've covered here, but this video should have equipped you with a solid foundation to begin collaborating on your own projects. If you're eager to dive in and expand your knowledge, the Git website offers a free book that delves into Git's intricacies with greater depth, and I highly recommend it. And if you've watched this far, I'd really appreciate a like and subscribe, and I'll see you soon.